Okay. So my topic was to analyze like the results of object detection through explainability, like briefly put in that way. And I was to give a draft of the table of contents for my thesis. So this is what I came up with, starting with introduction and explaining like some background and what's the purpose of the thesis and that sort of things. Then for like a bit broader background, I would introduce the concept of trustworthy AI, the principles that are related to that, and then concentrate more on the explainable AI. Then I would also introduce the object detection models that will be used in this work, which are YOLO and probably also segment anything, though that is not like 100% sure yet. Then the fourth part is about like introducing, I don't know, are they like models or some sort of things that can be used to explain the object detection. I did look at the heat maps, and in my opinion, they look like something that I could use, but I haven't been able to test anything yet because we haven't been getting the data because of the vacation. So everything has been delayed a bit. So that is connected to the experimental part. So I will have like these different cases what I will experiment, and it is like a video material. So there could be like different sub cases, even like within bigger cases. But yes, for that reason, since I don't have the data, I don't really know what the cases are yet. So the structure of this is just like a placeholder for further. And then in the end, analyzing the results and having a conclusion. And since I don't have like the proper use cases, but they could include something like this, so that the object detection model labels correctly all the moving parts in the video, and there are some safety regulations at the place where the videos are from, like for example that all the workers need to have a helmet, or there should be some minimal distance between two like machines. And then to think about like if it's possible to in some way analyze that, since the moving picture is in the 2D format. So, but like if there's one object in front of the other, can we sort of deduce that there is enough distance between them, like to sort of try to see it in a 3D way. But yeah, that's like the sort of plan. Okay.
So do you have more slides now to present?
No.
Okay, so then are there any comments from the audience, questions? So it seems you have a straightforward plan. You might want to narrow down a bit the scope, at least to start with. This use cases are important, but
Okay.
this is quite a broad domain. So I'm a bit worried that this is overwhelming, kind of the scope.
Okay.
So if you could narrow down and maybe pick one use case or one specific data set that you have easily available, that you have in mind, and focus on this now, or to start with. I mean, this can always then grow and evolve, but
Yes.
maybe start small,
Right.
and then let it grow. Yeah, regarding the table of contents, this is very good. So if you could go back to the slide with the table of contents.
I don't know.
Yeah.
Here.
So is there any comments from the audience, from the other ones, about the table of contents? Seems pretty clear, linear. Just as a note, it might be not then so useful to also write the thesis linear, or to do the work now in this linear fashion. So
Okay.
what was your idea now as the next step of your work, of your actual work? Did you now think about implementing specific methods?
Yes, when I'll get more data and like the models will be ready for use, because I'm not the one training the models.
Mhm.
So I will be just experimenting on them. So for
Mhm.
now, I'm just trying to write, I guess, as much as possible in a way before I start like experimenting more.
And by write, you mean the literature review?
Yes.
Yeah. So did you also think about formulating a research question? One catchy research question or guiding question that you want to answer with the thesis?
Yeah, I've been thinking about it, but I don't think I have one yet, like concrete for me. But yes, I'm sort of like trying to constantly think about it.
Yeah, but maybe this might also be useful now to focus, to lock in one research question. I mean, from what I see, a research question could be, what is the state of the art in explainability for object detection?
Okay.
And then you could start from there and say, okay, I'm interested in specific object detection applications. So then you could narrow it down. So what is the state of the art of explainable AI for object detection in warehouses? And even narrow it down more, in warehouses of Posti in Finland. So there you can choose, or it's a design choice how much you want to narrow it down, the scope.
Right.
I mean, this research question would then correspond to a literature review type of thesis.
Yes.
Then you could also, if you're interested in testing a specific hypothesis, like how much can another research question could then be, how much can we improve object detection using explainability or using explainable AI techniques? And then this would then be an experimental thesis where you would try out a given method, a given object detection method, and then you combine it with explainable AI, like these heat maps, which then tell you should maybe resize the input images or something. So they give you some hint how to improve it, and then you measure the improvement.
Right. Yes, these are good starting points that I
Yes.
can.
I mean, in general, if you are free of economic constraints, then I would say the research question should be, or the main criterion for the research question is that you're interested, that you're passionate about it, because you will spend some time about answering it and writing the thesis. But I understand you do the thesis in a company, so there are some constraints from the company perspective. They might, for example, be interested in specific object detection applications, like in warehouses, which I don't know. This is something you might then want to discuss and get feedback also from your advisor.
Okay, yeah.
Okay, very good. You have a very good plan. Just as I mentioned, think about a research question and maybe narrow the scope a bit. Yeah, and also don't worry about the length of the thesis. So don't start to count page numbers or try to achieve a certain number of pages for the review chapters.
Okay.
Yes. Anybody else wanting to share hints? I guess many of you also in the audience have written a master thesis. So if you remember when you were at Raili's stage, what would have helped you? Which hint?
I think as a general note, when writing the master thesis, finding that specific question is insanely hard. But the way that I thought it was best to actually approach was to keep on reading and find something that I completely disagreed or agreed with. And that way, finding a question on what you want to research on is a lot easier than if you're just focusing on what you have right now.
Yes, thank you.
Okay, thank you.
Yeah, so a very, very important task or work towards formulating these research questions is to read the literature, read papers. And I also encourage you, if you have an interesting paper and would like to discuss it, you can also use one of these group meetings to present us a paper and discuss specific claims in the paper that you are curious about or might disagree, as Diana said.
Okay.
Okay, so if there are no other comments or questions from you, Raili, then thanks again for this presentation.
Yeah, thank you.
And let's move on. Maybe ask now Rudolf.
Yes.
Yes, if you want to share some slides with us about Triton.
Sure. I don't have any slides to present, but I think we could go through the GitHub repository.
Yes,
that
that's
I have.
Perfect.
Can you see the screen?
Yes.
Okay, so this repository implements the Pangu weather prediction model, and well, it consists of 4 main Python files or scripts. First off, we have just the model like implementation. It just contains the definition of the model. Then we have a separate trainer file, which implements a trainer class, which is responsible for implementing the training loop and saving checkpoints and saving the model parameters and training metrics as a result of the training. Then we have a data handler file, which implements tools for basically creating the data set and pre-processing the data and creating the data loaders to be used in the training. And then finally, we have the main script, which is used to orchestrate the creation of or initializing the model and a trainer object and the data sets, and also defining the hyperparameters of the training and the model. And well, okay, so these are the 4 main files in this repository. And well, I have written some tutorial type content on the GitHub repository about how to use Conda in Triton. I have included also links to the Triton manual about the topics. And yes, well, maybe we could start by looking how the actual workflow goes from here. I will share another screen. Okay. So this is VSCode, and you can connect VSCode to a remote host. And in this case, I have connected my VSCode to Triton. And here on the left side, we can see the main script, the data handler script, model. The model is just defining the model as usual, and then the training script. Here are also some other things that I have git ignored, and let's take a look at the main script. So this is basically how Triton works, is that you submit a script to be run on the cluster, and basically this is the main script where you define the training parameters here and the model parameters. You initialize the model, the data set and data loaders, and then the trainer class, and you call the train method of the trainer class. And how do you submit this main script to Triton is by using a shell script, which is also included in the GitHub repository. So this is like a sort of an interface for the Triton cluster where you request the resources that you want to use. Basically the runtime, how much time you think the training of the model will take, how much memory you need, the GPUs, how many, and maybe what type of GPU you want. And how this works is you have a command called sbatch, and just type the shell script name here. Whoops. Like this, and press enter. And then it will go to the Triton's Slurm workload manager, which will allocate the resources for you and start running the script, this main script here. So this is like the basic overview of how the workflow goes here. Then maybe some specifics about this. When you are running this training script, you are calling the train method of the trainer class. The script will automatically create some files here on the same directory where the main script is. One such file is a checkpoint file, which is used to basically, if you request too little memory or too little time and your training doesn't finish as expected, or for some other reason the training fails, but the checkpointing is done such that you can continue from say last epoch that a checkpoint was saved on. Here is a parameter called save every, which says that save a checkpoint every 2 epochs. And this also makes it easier to, for example, I have last run the model for 20 epochs, and if I wanted to continue the training, I could just load the checkpoint, which it does here automatically. Or, well, it loads the checkpoint in the trainer class, but it does it automatically if a checkpoint exists. And it makes it easy to continue the training from where it was last finished. And well, also when the training finishes, it will also create, it will save the model parameters and training metrics. The training metrics include at this stage the training loss and then evaluation loss. And well, model parameters are the parameters resulting from the training. And yeah, these are created automatically as a result of running the training. Then maybe we could, one thing that I like to do, I will share another screen here.
Just a quick comment.
So the Triton has this Jupyter Notebook that you can access, and it will contain all the files that you have on the Triton. And I find these notebooks to be very helpful for the workflow. This makes it easier to, for example, create these visualizations about the training metrics, for example, or anything else that you will need to test, or if you want to run quickly some code, so you don't have to create a script and a shell script and submit it to the Triton. So for such tasks, the notebook is very, very useful. And there is a notebook Triton interface they offer. I suggest to use it. It's very nice. I think this was basically all I had to say about the workflow for now. Then, well, maybe we could discuss this is easily the largest model that I have ever worked with. And for now, these scripts that I have on Triton, they sometimes mention the execution modes such as single GPU or multi-GPU, but for now it only has the single GPU option implemented. And yeah, the model is very large. In the original paper, they said that they ran one batch on one GPU, and I have actually here the Triton has the same GPU. It's the V100 NVIDIA GPU with 32 gigabytes of RAM, and I had actually troubles of fitting the model onto the 32 gigabytes. So there is still some work to be done, like optimizing the memory efficiency of the model. Because, yeah, well, it wasn't like fitting to the memory constraints of the GPU. But, well, in here, we can make the model smaller by changing the model parameters. And yeah, I would be very, very happy if someone has like good tricks to suggest to make these deep learning models more memory efficient. Maybe take a look at the implementation of the model. I will leave a link to the Slack, to the GitHub repository. Which channel, by the way, should I put the link on?
You can use the general channel.
General. Okay.
Yes, and then there was a question regarding the resources. So can you is it possible that you request more compute power from Triton?
Yes, it is possible to request more GPUs. And basically, I think there are also GPUs that have more memory than the 32 gigabytes, but I haven't myself done that because I have been trying to basically replicate the model that the original authors have implemented, like such that it fits on the same GPU. But yes, it is possible to request more GPUs, but then the training scripts would need some modifications to use all of those GPUs.
Yeah.
I am going to do that at some point.
Very good. And then I had now, I was not clear. Could you remind me how is now this, so it seems this VS Studio is a super nice graphical user interface for coding on Triton.
Yes.
But how does this tie in with the notebook, with the Jupyter Notebook? What do you use the notebook for?
Oh, okay. Basically, the VS Code I use to develop these models and training script, and yeah, of course, this main script that is then submitted to the Triton. And the notebook then is it's a web-based, like it's on the web. They have let's see. So here, this is the Triton's manual, and they have a link to the Jupyter notebooks. And well, you would have to create your own notebook there, but you get the access to the like the file system of Triton, where you have all the same files that we saw in the VS Code.
So but you can do exactly the same. So these are alternatives to each other, or the notebook does something on top of what you did with the other script.
Yeah, well, this is basically a more agile way to run like small tasks. You cannot really, I don't think the notebook has, for example, GPUs to use. And maybe we could take a look at the Triton cluster. It is basically, it consists of nodes, and some nodes have GPUs and some don't. And this Jupyter notebook, where the link will go, it is running on a node where I don't think there is a GPU there.
Okay.
So this is, yeah.
You didn't do the same training that you did in the VS Code. It's not the same what you do here now in this notebook.
Yes, I'm not running the training on the notebook.
Okay.
Yes.
How do you get these plots then? This loss versus epoch?
Yes. This is basically so.
You read in the diagnostics from the checkpoints or the.
Yes.
I
Yes.
see.
This training metrics.pt is a file that is created by the training.
Okay. So is it more like the notebook you use to visualize the results you get from the other script?
Yes.
Okay.
Such, yeah.
Okay.
Like those smaller tasks, and maybe if you have something to debug, something you have to check, it's much easier to run like small pieces of code here to check a little things and also do the visualizations. But
yeah, I guess it's very convenient because in this notebook you can access the file system on Triton. So
yes.
you don't need to ship around the results you get from all this heavy number crunching. You store the results like in this PT file in the same file system that you can then access in this notebook.
Yes, exactly.
Yeah,
yes.
I see. Okay, very nice. Thanks a lot. And yeah, maybe we could have a follow-up presentation in some of the next group meetings where you go a bit more into the details of the model, of the deep learning model.
Yes, sure.
Yeah.
Sure. Yeah.
Okay. Thanks a lot again. Any other comments? So maybe some of you might need some large deep neural networks, and then you might do something similar as Rudolf, use the resources of our department cluster, computer cluster, Triton. Okay, so then next, maybe I would then ask Xu if you want to give us an update on your work on using deep learning for optimization.
Yes. I'll share my screen.
Yes.
Okay. I gave an update about the vehicle routing problems with deep learning. I don't have a slides for this meeting. And last time, I was intended to develop an experiment for vehicle routing problems on 2 different algorithms I talked about from papers. And one method is through this paper, use a GCNN method. So it is basically provide a GCNN for learning branch and bound variable selection policy for mixed integer linear programming. So what they did is collect strong branching examples on random generated like maximum set covering instance. And then they trained a GCNN with this feature. They transform a mixed integer programming problem into this bipartite state representation. And then they imitate the expert by classification. And here's the IPython file, and the code here generally used library called eco. It's developed by the same group in this paper. And so this eco it provides environments and standard benchmarks for evaluating this kind of combinatorial optimization algorithms by using SIP, which is a mixed integer programming solver. So the first instinct is to evaluate this model, implement this model here, and another approach for vehicle routing problem by using this library. But the problem is both ECO and this GCNN is designed for general combinatorial optimization. It's not especially for vehicle routing problem. And because the SIP, because general mixed integer linear programming is use branch and bound algorithm. But for vehicle routing problem, this method can be very computationally expensive. So usually vehicle routing problem use specific heuristics and algorithms. So the research about combinatorially natural optimization and vehicle routing problems is not exactly the same. And if we by using the ECO and this model, it can be very, like the results can be very computationally expensive, and we have to like change a lot of algorithm design to fit in this structure of this library. So I didn't I tried to change it, but then I realized it's not very worth it. So I also read others library about other literature about vehicle routing problem, and I found other specific literature I'm interested in about this area. So the first paper is in this area. So in this area, here's the several paper, 4 papers I'm interested in, and one is used the imitative learning for this capacitive vehicle routing problem, and this problem is typically by in the research area people use for vehicle routing. So it means that each vehicle is capacited. And so basically in this main area here is one related model. It's very generally researched. It's called hybrid model. And here's the 2 paper I'm intend to run the experiment, and why it's this one. So it provided open source about the implementation, but I'm still reading the source because it's in C++ instead of Python. And it used the very famous benchmark X instance on it compared several algorithms, including this 2 HJS model and OR tools. And here's another paper I'm also intend to. This one is haven't been published yet, and it's also it's implementation for the other journal paper. The code is in Python, but because it haven't been published, so there's no resource of this paper. So it used two famous benchmarks. One is this one is published last year in 2020, and this one is in 2017. So these are the two papers they ran among all the HGS related model. And here are the two papers I intend to experiment, but I haven't. And here's the other. It's another paper to solve competitive vehicle routing problems. And this paper is called learning to iterate. So here's the structure of the this one, the structure of this paper. So it's basically for vehicle routing problem, it's the input of this algorithm is the current solution and the instinct information. And the current solution, it means like a solution specific feature. And this one is the problem related feature. And what they do is they use this as input and and then for embedding from this attention or this okay. So this one is the big structure of their algorithm. So for a problem, it's either choose to so a problem instinct has a current feasible solution. So for this solution, it's either use the improvement operators to improve the solution, or it use a mental controller and choose either to improve use a improvement controller to improve the operations and go update the current solution, or it use a perturbation controller and to also cut the solution and choose a new one. So this one they used deep learning, and this part they used rule-based this controller. So it's like set up a parameter. So whether it's the iteration, it doesn't improve for example, X times, and then use this controller. And this one specifically, this part is used this structure. So with the current current solution and the instinct information as an input, the neural network produce a vector of action of these action probabilities and also the weights to the network and trained with policy.
Okay, so and you are now trying to implement this learning to improve
Yes.
method.
Yes.
But the challenge is that it's in C++.
No, it's in Python. The
Okay.
other paper I mentioned is in C++.
Okay.
This one. So
And
they are
okay. And for this learning to improve, you have already implemented some experiments or tried to reproduce any results in this paper?
I haven't tried to like use it for like I haven't figured a way how to improve it. Yeah, I'm trying to like implement the experiment.
Yeah, so there's no need that you improve it. So as a starting point, maybe you just try to reproduce the numerical experiments if they have in this learning to improve paper.
Yes, they do have.
Could you show us these results there? Are there some plots of loss functions?
Yes. So I haven't like totally read through the code because it's quite challenging. Everything is in the same file. So
this code is available or is from the authors?
it's from the authors.
Yeah. Okay. No, I meant in the paper. Could you show us the numerical results in the paper?
Oh yes. So here, the benchmark they used is a little bit not up to date because the paper is from 2019, and generally they use different benchmarks now. So I'm thinking maybe try to use the new benchmarks for this algorithm.
And a benchmark, by benchmark, you mean an ensemble of difficult optimization problems?
Yes.
Could you show us or give us an idea how these optimization problems are generated?
So for benchmark, you don't have to generate it yourself. It's already here.
Mm-hmm.
Yes, and for the training data, it can be easily generated by a lot of mixed integer solvers. For example, in this SAP or in this Google OR tools, or even by this eco library.
Mm-hmm.
Yeah.
Okay.
So this part of research and the HGS model is kind of non-related. So I'm thinking, but they are they are for the same problem, to solve the same problem, but use different method.
Yeah.
Yeah.
Okay. Yes. Thanks for the update. Yeah, I'm curious to see once you get this code running, to try out some of these optimization problems that the people from Lapenrante look at. So if I understood correctly, Arun is also solving such vehicle routing or interested in vehicle routing problems. And did he point out some competitor method that we should compare?
He just mentioned a very famous and heuristic, but it's it's generally used, and people based on this heuristic to combine it with deep learning method. So, and he also this website is he provided. Yeah.
So each each row here, this row here corresponds to a specific. No, in the other window. No, before.
Oh, this one.
Yes, here. Each row here corresponds to a specific optimization problem.
Yes. vehicle routing problem.
Yeah. So a data point in this machine learning application, a data point is an optimization problem. And the features of this optimization problem are its specification in the form of mathematical symbols like algebraic expressions, or as Xu pointed out in the beginning, you can represent such an optimization problem as a graph.
Yes, here's okay, here I'll show it here.
Yeah. So a
No,
data point
this-
is an optimization problem, and the features of this data point are, for example, the graph, and the quantity of interest is the solution to the optimization problem.
Yes.
So why not training a deep neural network to map from input, from the representation of the optimization problem to the solution? Okay. Yes, so again, thanks for the update. Are there any questions or comments from others?
As for the C++ code, maybe you can, is it possible to ask ChatGPT to transform it to Python?
Of course. I
Yeah.
mean, yes, you can ask, but I don't know how useful the answers are, I must say. But
Okay.
as I understood, there might be even more developed methods to translate code from C or C++ to Python. So maybe you Google a bit around.
Okay, I'll try it. And another thing is, so this paper is like recently, it's not published yet, but it's already like transferred C++ to their article.
Mm-hmm.
Okay.
What was the question? Sorry.
No question.
Okay, a comment.
Yeah.
I see. Okay. Good. Yeah, then we're almost at the end. I want to keep these meetings by 1 hour max strictly. So if any one of you wanted to present something, I kindly ask you for patience. We have the next meeting of similar form via Zoom in 1 week, same day, same time. Okay, thanks a lot, everybody. And I will then ask you explicitly, each one of you, for your consent, if I can share the recording, first of all, within the group, so that those who could not join us today can look it up. And the full public version would be, I would post the recording on my YouTube channel. But by default, nobody of you has given me consent yet. Okay. Thanks a lot, everybody, and have a nice week ahead. Bye.